Okay, in this section we're going to discuss the mean value theorem. Now before we get to the mean value theorem, we want to talk about Raleigh's theorem. And what it says is that if y equals f of x is continuous at every point of a closed interval from a to b and is differentiable at every point of its interior from a to b, if f of a equals f of b, then there's at least one number c in a to b where f prime of c is equal to 0. So if you have two equal y values in an interval, there's at least one place in between those 2 points where our slope is 0, or we have a horizontal tangent. Now look at this example. If you look at the top, you can see at A and at B, the y values are the same. In order for those y values to be the same here at A and B, if our graph is not just a constant graph, then it's going to have to either increase and then start decreasing back down to B, which gives it a maximum value here, a local maximum. Or it could possibly decrease and then increase back up to B. Okay, so unless it is a constant function, it has to do one of those two. Now, it is possible it could have more than one place where the slope is 0, as you see here. At A and B, you have the same y values, and it increases and decreases and increases and decreases and comes back to the same y value. So it has multiple places where the slope is 0. But in order for you to have two y values that are the same, you have to have some place where your slope is 0. Now even if it were a constant function, so like this yellow line through here, if it were a constant function, then every point between A and B would have a slope of 0. Now that does not hold if it's discontinuous. And you'll see at A it's discontinuous, and so you have an A and a B value. F of A and F of B are the same, but it never has a local maximum or minimum between those 2 points. Same thing with B. Since it's discontinuous, there is no place where the slope is equal to 0. Now look at this last one. They're the same, but it's not differentiable here at this point x sub 0. Otherwise, it wouldn't have a point. Remember we talked about when there's a point in a graph, it's not differentiable there. So it does not hold if all the hypotheses of the theorem do not hold. So it has to be continuous between A and B, and it has to be differentiable at every interior point. Now we can use that theorem to show that there's only one 0 of the polynomial y equals x cubed plus 3x plus 1 between -1 and +1. Okay, so if we wanted to show that there was only one real 0 here, then what we would do is we would combine Raleigh's theorem with the intermediate value theorem. Now remember, the intermediate value theorem said since y is -3 at x equals -1 and y is +5 at x equals 1, there has to be a 0 between there, as long as it's a continuous function, which all polynomials are. The only way we can go from a negative y value to a positive y value in an interval is for it to pass through 0 somewhere. So it does pass through 0. Now if we wanted to show that that's the only 0, how do we know that's the only 0? That it doesn't come up and back down and up and back down and cross more than one time? Then what we look at here is the first derivative. And f prime of x is 3x squared plus 3. Okay? And this f prime is never 0. 3x squared is a positive number, plus 3 still a positive number. There's no way that f prime of x is going to be 0. Now if there were two zeros, then Raleigh's theorem says that there would be a point between them where f prime of c was 0. And so the only way you could have like this 0 here and another 0 is if there was some point in between them for which f prime was 0. But there's nowhere in between this point and a point to the left or a point to the right where you would have a slope of 0.